it's always a tough balance between smart rigor and that unnecessarily delay that comes with a lot of experimentation and getting that big stat sig number. I think you actually said this in our pre-interview chat, like people not really appreciating the significance of statistical significance,
That's
always
true.
overdoing it.
People, yeah, I
But
mean, right. Yeah, I hate being punny on a digital format like this, but no, I mean, it's true. I don't think people really understand what statistical significance is. For
yeah.
example, if something is significant at the 0.05 or 95% confidence like level, what that means is one time out of 20, you'll be wrong, right? I mean, it's not like a perfect thing. What it means is data like this will show up erroneously one time out of 20. Are you comfortable with that? And at the 80% level, it'll show up one time out of 5. Well, you'll get the wrong answer. There's a statistician called Bonferroni, Italian statistician from, God, I don't know when, 1600s or hundreds. By the way, somebody's going to fact check us and I'm going to be off by several hundred years. But anyway, Bonferroni introduced this notion that you can't do your analysis. You can't do your experiment and then go looking for your hypotheses after you've done your analysis. You have to have your hypotheses up front, because if you're looking for patterns in the data and then you go cherry pick, you are going to draw conclusions aren't truly as strong as you believe. And so he's got this adjustment that I'm not going to bore your listeners with. It basically says you have to actually cut your statistical significance based on, having your hypotheses a priori. But back to what I was saying about the significance of significance, there's 3 ways to be statistically significant, right? The way that everybody thinks about is effect size, meaning you're comparing two things, and one of them, the metric you care about is like way up here and the other one is way down here. And that's statistically different. That's the one that everybody thinks about. That's effect size, right? But with a very small effect size, you can also be statistically significant if you have enough sample size.
Mhm.
So, for example, they discovered in the 50s or 60s or something like that, that aspirin reduces the rate of, heart attacks, right? You had to take like half an aspirin or low dose of aspirin. The effect size there is really small. But when you're dealing with life and death, really small counts for a lot, right? So if you do a study and you have 10,000 people and you're comparing, some of them got the aspirin, some of them didn't, and then there's a natural heart attack rate, and then you've cut that by 4%, or I mean, I don't know what the effect, it wasn't big. And in fact, with a small sample, you wouldn't be able to know. The variance it would be too noisy to be able to even measure a
Yeah.
4% impact or whatever the effect size was. But with a large sample size, which is what they had, they were able to confirm with statistical significance, you know what? This actually makes a difference. And when you're dealing with life and death, that's really important. And that's one of the things that, now is part of, medical science has accepted this and people understand it. And it's a really important life and death tool. So that's the second way, right? So the first way is effect size. That's what everybody thinks about. Sample size, you can take a small effect size and you can get to statistically significant results if you have a large enough sample, because that reduces your standard deviation, which means your variance is. And so then you can measure, you can discern two things being different, even if they're very similar averages, because your sample size is so big and your standard deviation is so small. The third way is sort of cheating, but for completeness, I'll mention it, which is that you can reduce your threshold for what you call significant, right? So a lot of people use alpha as 0.05, meaning that, it has to be, 1 in 20 chance of it being wrong or less. But you could also have alpha as 0.10 or 0.20 or 0.25. You move the goalpost.
Mhm.
Again, it's sort of cheating, but there are times when, it should be 0.01,
Mhm.
right? I mean, where you really need a high bar. Medical science would be a good example of that. And then there are times when it really doesn't matter that much, right? You're testing copy in a marketing communication, and indicatively, you want to have some idea about what the right answer is. You can just look at the averages, and that'll give you some idea. But if you have different sample sizes, you want to compare these things, and you want to know, hey, what's the chance this one is in fact better than that one? Well, you can calculate it and you can decide this is significant or this is not significant, but you have a yardstick that you've defined. Standardly, people use 0.05, but that's not universally the only option to use. So anyway, yes, statistical significance is something that's probably way more than your listeners care about, but I use it to illustrate that people are banding about terms and phrases that they don't deeply understand. They believe that significance is important. Some of them believe that if it doesn't achieve the statistical significance threshold, that the finding is not meaningful, which isn't necessarily true, right? So anyway, I'm just saying that there's sophistication here, and the important thing is to pair good business judgment with a solid understanding of the data. And if those two things don't happen to reside in the same human brain, that's okay. That's all right. You know? And so my general philosophy is you want to have, business people who can ask, important questions, and then people who understand the data who can provide meaningful answers.